Very good morning, my dear students. Today we are going to discuss the Verilog HDL. So this is actually comes under our autonomous syllabus. So in this we are going to discuss 5 units totally. The first unit is Introduction to Verilog HDL, and second unit is gate level modeling. Third unit is our data flow modeling, and fourth unit is behavioral modeling, and fifth unit is component test and verification. So these are the units which we are going to cover in this syllabus. First we will see what is HDL. You all know the HDL is the hardware description language. It is specialized language used to describe the structure and behavior of the digital circuits. So there are three different standards are used in this Verilog. One is Verilog, and another one is VHDL. It is actually very high speed hardware integrated circuit language, that is HDL. VHSIC HDL, very high speed integrated circuit hardware description language. Then the third one is that system language, system Verilog. So these are the three different standards which will be used in this HDL. So now we are going to discuss about this Verilog. So why do we go for this? First of all, you want to know why do we go for this. In 1971, Intel introduced that 4-bit processor 4004. It has the count of 250. So it uses the 10 micrometer technology. And in 2000, Pentium 4 processor has 42 million transistor. So it uses 180 nanometer technology. And in 2020, Apple introduced the 16 billion transistors for 5 nanometer technology. And in 2005, the NVIDIA introduced or used 208 billion transistors for 4 nanometer technology. Okay. So now today there is another technology which will be going to emerge, that is actually called as the Armstrong technology. So why do we go for this? First of all, you know, right? So in this VLSI, the number of transistor count is increased, that is chip size decreased. So the 4 meter, that is up to 4 nanometer we are using now. So then in the forthcoming we are going to use the Armstrong technology. Okay. So then first of we are going to see what is Verilog. So this Verilog is a hardware description language. It is used to describe the digital system and circuits in the form of a code. Okay, it was developed by the Gateway Design Automation in the mid-90s, and later it is acquired by the Cadence. Actually, it is introduced by the Gateway Automation, and now it is acquired by the Cadence. Okay, so why we are using this Verilog, and what is the advantage of going for this Verilog? The syntax is very simpler and better to support for behavioral modeling, and it uses for higher level of subtraction, and also it is a better tool for support. Okay, so then what are the various applications which can be used for this Verilog? In embedded system domain, we can use this Verilog, as well as digital image processing, digital signal processing, networking, ASIC design, and for autonomous vehicles also we can use this. In real time we can use this Verilog applications. Okay, and we are going to discuss various levels of abstractions of this Verilog. So there are three different levels of abstractions are used. One is that gate level modeling, or it can also be called as structural level modeling. So then the next one is that data flow modeling and behavioral modeling. Okay, so these are the three varieties of data, that is different modeling of the Verilog. Okay, so first of all we are going to see what is structural modeling. It can also be called as the gate level modeling. If we are using it is actually the lowest level of abstraction, and it uses the gate primitives, that is already predefined gate is used to describe the hardware. So that's called as that structural level modeling or gate level modeling, because a predefined gate is used here. So that's why it's called as the gate level modeling. Here we may have then example program. Here half adder is given as an example for this. In this half adder we are having two gates. One is XOR gate, and another one is AND gate. So for this we wrote a simple program using the Verilog. So if you want to write the code using that Verilog, first you should write the module. So module, and this module name is half adder we are giving. This is actually an identifier. It can be given on our own, and in the bracket we should give the port list. That is, what are the input and output we are going to use. So in input we are going to use two inputs, A and B, and in output we are using sum and carry. Okay. So then in XOR gate we are using two inputs. This X1 is called as that instantiation, and sum is the output, A and B are the input. A similar kind, the AND gate uses two inputs, A and B, and the output is carry. So like that we should write, and every module should be stop with an end module, right? So compulsorily the module name, that is module declaration, and the end module should be there. In between that module and end module we should have the content, right? So this is the example for the structural modeling. If you are writing the code using the gate level modeling, then it is called as that is, if you are using writing the code using the gates, then it is called there is predefined gate, then it is called as structural modeling. Okay. So then the data flow modeling. So this data flow modeling is medium level model, that is moderate level of abstraction it has, right? So how can we describe this data flow modeling is that it can be used to transform the registers using Boolean equations, right? That is, if uses the assign keyword and logical operators like and, or negation operator if you are using, then it can be, that is, it is used to give the relation in between the and or. That is okay. So this is an example for the data flow modeling. Using assign we are writing. Okay. So then the third one is the behavioral modeling. If you are describing the behavior of the circuit, then it is called as behavioral modeling. So it can be represented use that always. Okay. So if you are using always, then it can be set that as a behavioral modeling. Thank you.